Question 1. If you only want to target harder questions and you want to skip easier questions, at any point, at any page, at any question, you can let me know that this is something that you find easy, and we can simply jump on to the next one. Maybe the next question, maybe the next page, maybe the next topic.
All right. B.
Good, B. And which element is that?
It's chlorine, going from 0 to +5.
Good. Let's move to 2.
Charlie.
Good. Moving on. 3.
So it's either A or C, right?
Yes, perfect. It's either A or C.
Well,
Good.
KClO3, one will be, I think, potassium chloride, the one compound.
Mm-hmm.
Mm. What can be the other one? ClO or something like that? Cl2.
It can be Cl2O7. It can be KClO5.
It can be these two. Okay.
Any one among these two.
So when you said Cl2O7
Yes,
and one was KClO5,
right.
is this
Do
some
you want?
equation we're supposed to know, or
No, you're not supposed to know the entire equation. That's
so
not,
like
not how it works. Now, how would you know? Yes, that's a good point. Now, when you go to chapter number 10 and you talk about periodicity, at the end of that chapter, we talk about oxides and chlorides. In the case of oxides, the oxides that chlorine forms, there is an oxide mentioned over here with +7 charge of chlorine, that is Cl2O7. From there, you know that this +7 is a possibility. However, you are not familiar with KClO5 since that's not mentioned anywhere in the book.
But Cl2O7 is.
Cl2O7 is, yes. Periodicity chapter, oxides topic.
All right, I'll see. So it would be Charlie then.
It would be Charlie then, right? I guess this gives you the idea.
Yeah.
Okay. +3 and -1 is something that most students go for. Now, let me elaborate this. If you go with +3 and -1, this one, which seems to be the most obvious option. Now, this is, the students go for this one because they find it really easy. They go for KClO2 plus KCl, and they tend to balance the equation, right? So they try to do it, but you won't be able to come up with these ratios. Okay?
Right.
Because this and then this requires this, you will always fall short of some of the oxygen atoms. So maybe this. Yeah, this goes for that. This goes for that. Yeah, but still there's a mixture of two chlorine compounds. But he only talked about the chlorine compound. Chlorine is the only element whose oxidation number changes in this reaction, so this is not possible. Yeah, he mentioned it clearly. This one is not possible, right? Even if we come with this 3:1 ratios, this is not possible because of this line. Okay.
Yeah.
Now, going with another one, KClO3, giving us KCl plus Cl2O7. 3, KCl. No, that's not how it works. We have unbalanced number of chlorine atoms. Of course, we have also oxygen unbalance.
Yeah.
Okay, let's try this one out. Wait a second. That's not it. That's not how it would work. This one would work. Does it make sense?
KClO4.
KClO4 because this is -2 and 4. This is +7 and this is +1. That's how the whole thing balances.
Yeah.
It's not even KClO5 because KClO5 means chlorine goes with +9, which doesn't seem to be possible. The higher, usually most of the elements go is +7. In this case,
highest.
And most of the time the highest in A levels at least they go to up to +7. We don't go with anything more than +7 A levels.
There is a possibility of +7 excluding 11.
Yeah, there is a possibility. There might be. Chemistry has a huge variety. I can't say anything for sure. We're still working. We're still exploring. So putting something out there as a hard and fast rule would not be a good idea.
Right.
Well, we put this as 3 and this is 4. That balances chlorine and potassium, but does not balance oxygen.
Yeah.
It won't form compound like that. The other way around. Wait a second. 3, 4. There you go. I guess now it's balanced, completely balanced.
Yeah, now it is.
This is the one we're talking about. No other element changes oxidation number in the reaction, 3:1, and also +7 and -1. So with a few practices, you come to get to the right equation. But this definitely requires time. Now, the point you picked in the start, and I'm assuming you picked up the same one, is that it can't be both plus and plus at the same time. If that's a redox reaction, or that's a disproportionation reaction, the two possibilities, it has to be a positive and a negative, a positive and a negative. Since this one doesn't balance, we can go with this one. I hope that makes sense. Okay, moving on. Four.
Delta.
Good. 5.
Set the 2 in the solution containing VO. The 2 is for what? Oxygen or chlorine?
It's for oxygen. VOCl2. It should be the subscript. It is a typo error. So this must mean VO2Cl.
All right. Beta.
Right, good. I hope you understand the fact that if both of them are over on this side, both of them are negative. So this one's plus
Yeah, that
5
would be positive.
and this one's also plus 5. So 0, 0. 6 is too easy, leave 6. Yeah, this is a good one. 7.
Delta.
Okay, right. And what was the sum, by the way, in delta?
Plus 2.
All right, good. Moving on. 8.
Alpha.
Alpha. Why?
Multiply the upper equation by 3 to balance the number of electrons. The electrons would cancel out, and we will do 14H plus minus 6H plus, that would be 8H plus on the reactant side.
Good.
That was coming in alpha.
Right, good, good. Whether you talk about in terms of hydrogen ions or you talk about in terms of, after the electron balance, you talk about in terms of multiplication of 3. There must be 3 over here. which means this equation is wrong.
Yeah, B was
Since the
cancelled out.
7 should stay, and these two equations are also wrong. So this is the only one right? There are multiple ways to proceed this one and get it correct. No, too easy. Let's try 10. Since it's depiction and not actual lines, it might take you a little more time to solve it. That's why.
All right. Just one question. The sum on both sides of the, like when we calculate the sum, it should be equal to 0, like multiplying with the oxidation state, right?
No, it should be equal. It shouldn't be exactly 0. It should be equal on both sides.
Equal. Yeah, equal on both sides. All right. Charlie?
Good. Go ahead. 11.
All right.
Since you have already practiced the hint in question number 10, it shouldn't be a problem in question number 11.
Yeah. So can you solve it?
Okay, sure. All right. Let's collect all the hints. We have NH3, OH, and the whole thing is positive, and that reacts with Fe3 plus ions. The products that it gives us is Fe2 plus ions. It also gives us hydrogen ions. It also gives us water, and it gives us a compound of nitrogen. We don't know what that is. Okay. Now, one thing for sure is that the mole ratio is 1:2. 1 is for hydroxyl ammonium, and 2 is for iron 3 ions. This one is for sure 1, and this one is 2. Now, since this one is 2, this one is also supposed to be 2. So the difference over here is what? This one is actually getting 2 electrons, 1 electron each, a total difference of 2 electrons. Right? Now, pay attention that this one is -3. Get the point?
The
Nitrogen alone in the whole thing is -3.
Yeah.
Wait a second. Then how come it's a plus? Hydroxyl ammonium ions. How come they are a plus? If that's -3, if that's +1 into 3, that's balance. If that's -2, if that's +1, the whole thing turns out to be -1. So if it's not -1, if it's +1, then n is not -3. Okay, let's change it.
Are they doing NH4 plus NOH minus? Will that one be possible?
Then it should be a whole compound without a plus sign if it's NH4. Because NH4 positive OH is ammonium hydroxide, it is supposed to be 0. It is not supposed to be positive. Now, and when you take an H positive out of it from NH4 OH, it shouldn't become positive. It should become -1. This is what doesn't make sense to me, but yeah, let's go with this. So this is into 3. So this whole is -1. This is +3. So this is +2. Okay. I guess, no, not +2. Wait.
Plus, yeah.
Since we need to find this one out, x plus 3 minus 2 plus 1 is equal to, sorry, plus, since the whole thing is positive, plus 1. So x is equal to 2 minus 4 plus 1 plus 1 minus 4 plus 2. Yeah, everything's correct.
It will be plus
so
3.
What?
-1 for
nitrogen.
For nitrogen?
Yeah, nitrogen. See, this +3 is for hydrogen. This -2 is for oxygen. This +1 is for this hydrogen. This +1 is an overcharge of the ion. Make sense? And X is something we need to find out for nitrogen. Clear enough?
Yeah.
When I take these values over here, this -2 becomes +2. This +3 and +1 would become -4. And this +1 stays +1. So the overall answer is -1. Good enough?
Yes.
Since I take all of this over here, that's what this is.
Yeah.
Okay, so this is -1. Since we are talking about 2 electron change, so this -1 should be changed differently. and the change should be all the way to +1. 2 electron difference. Since iron and nitrogen are the only two compounds which are changing their states for this redox reaction. And it's a redox reaction as mentioned in the first line. This is the only one in which this is 1, 2, -2. So the overall is equal to 0. Okay, this was never an answer, -3. This was never an answer, +4. The problem was with B +1, this one, or C +2, this one. But this is the correct answer since the difference of 2 steps because of this electron would be +1, from -1 to +1. So we can safely say that iron reduced and this one oxidized, nitrogen oxidized.
All right.
So this one is N2.
Got it.
And of course, we can balance the equation after.
Yeah.
Because I guess if I put a 2 over here, this would balance nitrogens. But that's not the point. The mole ratio of reacting was 1:2. So we can't put a bigger number. Well, this solves everything, but this doesn't solve this balancing. I'm going to look it up.
All right.
It solves every piece of answer for me except for the balancing part. Well, if I might start balancing it, I put a 2 over here, then I might have to put a 4 over here and 4 with iron. It may balance the whole equation. I'm not trying all the way through. Do go ahead with this 2 and try to balance the whole equation. If you end up with 2 with the hydroxyl ammonium ions and 4 with each iron ion,
4, yeah,
it would still be 1:2, because the whole thing would be 2:4. So go through with this. Maybe you're able to balance it with 2s and 4s. Then the question would be correct. Okay.
All right.
You can try it a little later. We can discuss it in the next sitting. Okay. Let's clear everything up. Let's move ahead. Too easy. Repetition actually. Too easy. Let's go with 14. 14 is a little bit easy. And we'll go with 14 and 15.
All right. $14 is delta.
Right. That's the only reason I went for this reaction, because we haven't practiced a false positive yet. It might look like a redox reaction. It isn't actually a redox reaction. That's why I wanted you to try this. This is the first for of its type in this today's practice 15. if you're good with the basics, or what we say, 4 different definitions of oxidation and reduction, you would easily be able to solve this. Sometimes the most basic of questions are the most difficult ones to answer.
Yeah. Delta?
Great, delta. Okay, remember, it doesn't exactly have to be oxygen every time. It can be a gain of oxygen. Remember, if I define, it can be a gain of oxygen, it can be a loss of hydrogen, it can be a loss of electron, or it can be an increase in oxidation state. These are the 4 ways we defined. Now, every reaction does not necessarily have to consider oxygen. So this is not necessarily true for
Yeah, I
every
tried it
single
with
reaction.
chlorine, and in that it was being like
Yeah, for example, Na
oxidation
is
state.
being converted into Na positive by the loss of electron. Then you find no oxygen in this reaction. So first one is not true, no hydrogen in this reaction. Second one is not true. It's actually the loss of electron, which isn't mentioned over here, right? It can be a disproportionation reaction, so this B is not correct. This is definitely not correct. So it's totally opposite of what we are talking about. And this is the only one that would be correct, which is this, right? Because it increased from 0 to +1. So there is definitely an increase in oxidation state.
Right.
Mathematically speaking, from a smaller number to a bigger number is oxidation. From a bigger number to a smaller number, arithmetically, is reduction, right? I guess this clarifies it. So 16.
Alpha.
Alpha, perfect. Let us both oxidize and reduce because this is a disproportionation reaction.
Right.
Okay. Moving on with, nah, too easy. Yeah, this one's good. 18. Definitely could require some working. It's not that it's too difficult, but since you are going with a series-wise reaction, sometimes students make mistakes.
Charlie.
Yeah, perfect, Charlie. Good. Okay. Mhm. Easy. We're already done with this one. Now, you will see many questions regarding the simple titrations or the redox reactions between the potassium dichromate 6 ions or potassium manganate 7 ions with iron 2. So you would be familiar with these equations. If you memorize these equations during practice, you're going to be pretty speedy in your actual question and exams.
Yeah, all right.
So let's also skip 21. Let's go with 22.
Charlie.
Right, and that is manganese from +7 all the way to +2, which is a change of 5 electrons. That's the biggest change so far. All right, let's call it a day then, right?